Hello, I'm Jordan Kovaljev. I will make a small demonstration of a software for visual data exploration. First, let's start with a small presentation to introduce the concepts which will be illustrated later. What does a database contain? It contains simple data and it does not contain information and knowledge, but information and knowledge are hidden in the simple facts which the database stores. Simple facts like employees number or an income of a company can bring us to more important observations, and we can confidently say if a company is big or small compared to other companies. If we combine facts from different categories, we can make relationships between data, and we can have information like bigger companies have bigger income. These are already conclusions. And we can be drawn to find exceptions from these rules, like are there small companies which have big income? And the most important thing is the knowledge of why do these small companies have that big income? What are the similarities between them which make them so special? And information and knowledge has to be discovered. This is why we need to support the human analytical process with software and information visualization. Data information visualization is a suitable tool because it uses the big advantage of human perception to immediately recognize patterns. And we have to keep in mind the limitations of the people of human perception, which is the very limited capacity of short-term memory. Research has found out that the human analytical process goes into several steps. The first step being the orientation phase. Then we go to exploration, then deepening phase and assessment. In the orientation phase, we want to know what type of data do we have, how many data do we have, what is the context which we are working in, and then we start with exploration and we look at the simple facts and we compare them together in order to understand what is big, what is small, what is an exception, and what is large. Then we go to a deepening phase and we look into some relationships. We have to be able to search, we have to be able to filter, we have to be able to store our search results, and we have to be able to make annotations. Then in the assessment phase, we need to model our theory into the software, and the software has to provide us the means to go back to the data and either confirm our theory or say that the theory is not valid. Important thing here is that during this process the human being will be constantly switching from phase to phase. We will always need to go back to the orientation phase, to the data, to see the big data, and then we will go into smaller details, and then we will go back to the big details. And some keywords which the software should support are we need to save the search results always. We need to support this data growth, because while we are analyzing, we create new data constantly, and the software has to store this data and has to make it available for us again when we need it, and we will need it. Um, then we need to provide intuitive tools for searching and filtering and for data comparison. Now I will show a software which illustrates those concepts. I will connect to a database which stores financial data for a couple of thousands of companies. And let's see, what do we have here on the left? is the type of data that we have. We have a company name, we have the legal status, legal form, web address, the type of the company. We have board members. For some of the companies, we have employees. For each year, we have a financial profile, which stores several facts, publicity, and all this type of data, shareholder information, trade descriptions, and peer groups. Let's start looking into the data in this first phase to understand what do we have. So here we can find the names of all the companies, of everyone. We can see that we have some of them are active, some of them are inactive, and we can see that in a pie chart. And we immediately discover that the majority of our companies is actually active, and this will be almost 100%. Then we have legal status, an independent indicator. We have a more interesting distribution here in this independent indicator. This is something we might be observing in a later phase. The type of a company, then the industry in which the company operates, the stock sign for every company. Then, for example, in the board member, employees, let's see, we have small companies. The majority of the companies is small, and then we have large companies, like having almost 500,000 employees are the biggest companies here. Then we have the financial profiles, where we can see a lot of numbers. Operating revenue. We can have several different visualizations of that, which might be suitable or not. For the category, we have profit before tax, the total assets of the company, we have cash flow, current ratio, what else? Solvency ratio is another interesting thing to see that most of the companies have a solvency ratio larger than 0. And now, after we already know what is big, what is small, let's open the company profile of a single company and see what does it contain. Well, for example, this company is on the stock market, and we can see how the stock has been moving through the years. For this one as well, and we can see this simple data, the structured data of the company. This is Adidas. It has the independent indicator of A+. We have information about the employees number. We have its financial profile. Then what else do we have? We have the shareholders information. We see that we have one company which is holding shares in Adidas. Which one is it? It is an unknown, not very famous company. Grundstückgesellschaft. Then a company which has more shareholders, for example this one. It might be interesting to discover relationships between those companies, so we will save it for later. And now let's define this movement on the stock exchange as the Adidas collapse. During the crisis, and I will make it in red because it's a negative trend. This is my own annotation, and now I have currently created some more data because this trend is my own observation. Now I would like to find other companies which have similar trends, and I will start the search, and then I want to see all of those findings, and I see that in most of these companies, when this specific trend is coming, it is around the collapse of the stock exchange in the 2008-2009 period. So I would like to make an annotation in the company profiles for all of these companies because I'm interested in this trend, and I will add this trend to all of them. Then when I open this ACW, I already see that it has been annotated here, and I can show it into the local graph. Then I find another interesting thing about this company. It has been constantly growing until it collapsed. And then I'd like to search for some other companies like that which have the same. So this would be ACW growth, and I will make it in green just to remember that it's a growth visually. I'll search for it, and I will annotate all these companies, and I can look at it. Yeah, it looks similar. For example, Adidas is here again. So Adidas has already both these trends, and now I would like to be able to compare the financial profiles of these companies, if I will find anything in common, if I will find a pattern, and I will go deeper into my exploration, and I will create a company pool with all companies that had the Adidas collapse trends, and I would like to compare them with all companies that had the ACW growth trend and see if there are some similarities. Let's see the master data. All companies are active. They're all AG, which is the abbreviation for a company being on the stock exchange in Germany. They have the same independent indicators, but let's see how many of those. Okay, so here also they're very similar. Web address, the company type is industrial and financial company. Well, here we have a difference. We can start digging deeper into that because financial companies have the negative trend, while financial companies don't have this positive growth. Alright, now let's check the financial profile. Let's open this solvency ratio. Now the red bars in the background indicate the global data, which is for all the companies, and the blue bars indicate the values for the companies which I have been filtered. This will be only the companies with the falling trend, and here the blue ones will be only the companies with the growing trend. And I can see a pattern here because they're all positive. They all have solvency ratio greater than 0. And now, before I urge into the conclusion that all these companies have it, I would ask myself, maybe it is because all the companies which are on the stock exchange basically have this solvency ratio greater than 0. And I will go back to this slide and I will open the solvency ratio and I will filter all companies which have solvency ratio. No, I'll do another thing. I will use this AG because this gives me the companies which are on the stock exchange. So let's see all companies which contain AG in their company type, legal form. I find a little bit more than 1000, then listed. I am annotating those companies. Now let's see their solvency rate. The listed companies I'm interested in are here. I will create a new pool and I will go to the solvency ratio and I see that there are a lot of companies which are on the stock market but have a negative solvency ratio. This is why I would like to create another split here. I will look at the solvency ratio and I will create less than 0. Solvency small. I will create one which is at least 0. This will be the solvency big. And then I'll go back to my exploration. I will combine the small companies which are also listed by an intersection, and I will combine the solvency big companies which are listed, and I'll start comparing those. Now let's see first the solvency ratio. Here we have all the companies which are listed on the stock exchange. In this column we will see the stock companies which are listed on the stock exchange and have a small solvency ratio, and in this company we will see the companies that are that have a large solvency ratio and are listed on the stock exchange. Let's start comparing those. Operating revenue. Okay, here we have a pattern. The companies with small solvency ratio have small operating revenue. The other ones have larger. Profit before tax, same pattern. Here we have another relationship, and we find a lot of relationships between these companies in the way we split those. So we found the perfect one split which gives us more insights. Let's see this independent indicator. Company name, the legal status. Alright, we have a lot of companies in bankruptcy here. And active, inactive. Or here is another very interesting observation. Companies which are on the stock market and have a large solvency ratio, greater than 0 actually, also have the independent indicator C or C+, which the companies with a small solvency ratio don't have. Now, starting with these patterns, we can go back and forth into the data, make another observations, make another annotations, so that we can continue with our findings until we prove our theory. And now I would like to switch to another database because this software is generic and it can simply connect to a different database and show different data sets immediately because it analyzes the structure of the database and builds its own queries. It's a dynamic, and I would just like to demonstrate that.